We're here in Joshua Tree, California at an ECOPOD wastewater treatment plant. This treatment plant is located just outside the entrance to Joshua Tree National Park, and it services a high-end camping facility. This facility has about 50 campsites with showers, bathrooms, a welcome center where people can get food and drinks. The major challenge with this project are the effluent requirements. The local regulatory agency required a low total nitrogen effluent coming out of the treatment system. So because of this, the design used a staged denitrifying approach, where it went from BOD removal to nitrification to denitrification. So in the design stage of this project, the engineers decided to use the ECOPOD treatment system because it's a submerged attached growth process. This process is great for remote, rural applications because it allows for a really durable and robust treatment performance. So the media used inside the ECOPOD has vertical flutes. And the reason why we use vertical flutes is so that when the biofilm that grows on that media grows big enough and thick enough, the aeration provided underneath has a scouring effect across and sloughs off any excess buildup to prevent fouling. The excess buildup then falls to the bottom of the tank where it then can be pumped out by a pumper. So one of the big benefits of the self-cleaning and scouring of the media is that there's very little maintenance. It's self-cleaning, self-regulating, and you don't have to get in there and replace the media or clean it out. So for this project, the ECOPODs are installed inside of precast concrete tanks. This allows for a lot of design flexibility and where we can fabricate the ECOPODs to fit inside of the local precasters' tanks. So going through the treatment train of this facility, the wastewater first enters the primary settling tank. And as the name sounds, the purpose of this tank is to settle out the solids to the bottom and the scum to the top. The clear zone then leaves through 2 effluent filters, which are there to hold back any remaining floating solids. The wastewater then flows into the flow equalization basin. This tank is used to buffer out any peak or spikes in flows. There is duplex time dose pumps in this tank, which dose over to the BOD and nitrification reactor. So in this reactor, there is an ECOPOD with aeration being supplied. The purpose of this ECOPOD is to digest the BOD and also nitrify the ammonia. After this has taken place, the wastewater then enters the denitrifying reactor. This stage has an ECOPOD inside of it. However, there's no oxygen or air being supplied to the ECOPOD. There is hookup to the blower, and it's only there for periodic scouring and cleaning. In this denitrifying reactor, we have a carbon dosing system along with a mixer to allow the denitrification process to occur. After the wastewater has been denitrified, the wastewater then goes into a reaeration basin with an ECOPOD that is used to polish off any remaining BOD. Next, the wastewater flows into a dose tank where there are duplex submersible pumps which dose out to a subsurface drain field for final disposal.